Hello everyone, welcome once again to another exploratory analysis tutorial by Team Slidescope. In this part, we are trying to create a USA King County house sales analysis dashboard on the basis of a data set that we have received from Kaggle. And here you can see we are trying to predict sales price, and we are seeing what different features have effect on sales price and which features have little effect like on the overall sales price. So for example, average sales price by different property type, average sales by price by year and quarter. This is average of adjusted sale price by year build. This is sales year. And this is average sales price by number of living units in that area, average price by number of bathrooms, bedrooms, and this is the quality of building. So you can see the effect here, average price by square feet in basement, number of properties and average price by the square foot of living, square foot lot area, and the adjusted average sales price, where we can see for smaller values also, like when you have some outliers. So we will learn how to apply these interactive filters, like if the construction is new construction is false or new construction is true, what type of effects do we have. So everything that you see here you will learn in this project. We'll load the data set and build everything from scratch and design them and teach you. So let's get started. So the data set that we are using in this project is King County House Sales USA data set available on this Kaggle URL, and you can see it originates from a book, Practical Statistics for Data Scientists, and other information about the data set in its columns are given here. This is basically the data set where we have document date, sales price, we have property type, they have given YM, year and month of the sale, and this is Zillow Home Value Index, Zillow Home Value Index in normalized form, sales price adjusted for inflation, number of residential units on the property, square foot, etc. We also have indicates whether the property is new construction, zip code, estimated value of improvements, that is in building structure, land value, level of traffic related noise. And the purpose of this type of data set is to create a predictive model that analyzes house prices. So you can consider the house price, for example sales price, as a target field and try to see what type of effect do these different features have, like number of bathrooms, number of bedrooms, etc. What type of effects do these type of features have on the sales price. So this is something that will need exploratory analysis, and we will start with that. To start analysis, we will simply open Power BI desktop and we will connect the data. Data is given as a CSV file. So we will open that particular folder where our sales data is there. Now we can check whether every column is properly mapped with their headers, etc. are proper, and then we will load the data. Otherwise we will fix headers in Power Query editor. And now we will prepare our canvas quickly. So go to canvas. In canvas background you can select any color. So let's go with any color here and we can give it a background. Now on this we will add a text box stating what we are trying to do here. So we are doing exploratory analysis. So we can simply write USA King County house sales analysis or something like that. So let's write that USA King County house sales analysis, and here we can just make our heading approximately 70% in width. We can use font size as 28. We can make it bold, and here we can align it to center. For font we can either do this, or what we can do, we can give it a white color font and we can disable the background. So whenever we have any element in Power BI, if you will select, you will see effects. In effects you will see background. So if you want to give a transparent background, you can do that. For visual border, we can enable a border and select a color for it. So this way we can create our heading. And if you want to reduce margin and padding, from here you can go to properties. Here you have padding, so like you can reduce the margin and padding from here. So this is optional, and we can, so that we can make the heading size smaller. Just for, because we are doing some real estate related work, if you want to add some relevant image, you can add that as well. Just for reference, I am adding this image here. I will change that later. This is optional. So this image was created using Canva. Whenever we try to do exploratory analysis in such data sets, uh, where we have to create a machine learning model as well, so we have to predict sale price, and here is adjusted sale price also, which is adjusted for inflation. So you can keep any one of them as your target field, and then you want to analyze what is effect of different categorical fields, like property type, or here also we have whether it's a new construction. So what is the effect of this kind of fields here, and what is the effect of other properties, like you know living units, square foot, lot, etc. So we will start one by one. So in the data set order, we have document date, sale price, and year and month of sale. So first we have property type, and let's see what is the average price of properties on the basis of property type, and whether this particular column has effect on the overall pricing. So we are going to use adjusted sales price here. One thing that we can do is, in our table view, or in this particular case, we can select that this sales price or adjusted sales price are all in dollars. So we can make them, you know or format them like that. Make sure date is properly read as date, that is important. And this is year month also, so they are both dates, and that's why you can see we have the date hierarchy. So this is important. Okay, now this is property type, and we will use a simple stacked column chart. And for that stacked column chart, we will see property type wise average pricing. So that's why we will put property type on x-axis, because the whatever columns are there, we want to see whether, I'm repeating this, whether they have effect on sales price or not. So that's why we will know what is their correlation or what is their weightage when we will create the model, whether we have to drop them or we have to keep them. So now if we put adjusted sales price, and if we do an average here, right? So this is average of adjusted sale price by property type, which we can simply write as average sales price by property type. And here we can get one interesting thing, that for properties with single family property type, their average price is more, and multiplex and townhouse have lower average price as per the data set. Here if you want to adjust some properties, like we have column color, if you want to use the background theme color, you can select that. In general tab also we have title, So first of all, we can align the title in center and adjust its heading. So if you want to show what that average price is, so again, so whenever we will click a visual, so we will see its build visual properties, from where we can change the name, and we can put values here like as a legend or something. And here we have a format your visual part, where we have other information like what is the x-axis color. For example, this is x-axis color. In x-axis we have values. So if we adjust the values, okay, then we have title. This is title. We can adjust the title color also. I'm just giving different colors just to teach you the difference. So this is title. So whenever you have to adjust them, you can adjust them from here. Let's say, okay, and this is y-axis, so you can do the same in y-axis as well. For example, in y-axis, these are the values, the range that it is showing. Let's select this. Okay, now here if you will scroll down, you will find a lot of settings, but one of them is data labels. So when you will enable data label, you can see we will be able to see these values. So this is important, and when it is inside the column, then you can see it is appearing as a white color automatically, and when it is outside, it is appearing in a dark color. So you can adjust those things as well. Next, we can show trend of pricing. So we have YM, this is year and month of sale. For that, we will create a line chart, and in this line chart, on x-axis we are going to put date, because we want to see date wise pricing trend, and then we will select the adjusted price on our y-axis. So you can see sum of pricing was more and it is less here, and this is totally because of number of samples also. So we have to select average. So here you can see when it started from 2006, pricing was going up to 2013, but for some reason it dropped from 2013, 2014 and 15. So this also gives us information that we have data from 2006 to 2015, and here we can use the same styling. So you can go to home tab, format painter, and apply here, and this will give us the information. Now we also have our line based settings here, like if you want to show the line as a solid line, it can be linear or smooth, anything that you want to show. And for your line you can also select a particular color. So we can go with the theme color that we are going with, and this is average of adjusted price. For data labels, we can use a different color for value. So I will go with this color. If you want, you can simply convert it to area chart just to give the shaded portion, or you can keep it like that. When we have area chart, we can again, we have to select the line color and shaded area, so we can do that. So this tells us a good information about how pricing is being affected by different years. Here there is one more thing, because this is a date hierarchy. So for example, you want to show monthly pricing, so you can click here and you can see the monthly trend. You can see like that. Okay, this is monthly trend. If you will click up and adjust it here, so here also you can see how this is average of adjusted sale price by year and quarter. You can keep it like that. I will just rename for this visual as average sales price. By year and quarter, it will automatically adjust because it's a dynamic thing. Average sales price by year, and you can click on this drill down, like to expand all down one level in the hierarchy. Next value that you can see is ZHVI. So this is Zillow Home Value Index. Zillow Home Value Index is a metric that is created by Zillow to track the typical home value in a given region. So it's in our case it is given as Zillow Home Value Index average price. This usually refers to the typical home value in a region, not the average in the mathematical sense, but more like the median or a smooth estimate. Its uses are to help track overall housing market trend for an area. Examples are if the Zillow Home Value Index for San Francisco is $1.2 million, that's Zillow's estimate of what a typical home is worth in that particular area. Then in case of normalized, this is the version of ZHVI that has been adjusted to a baseline. Often so you can compare changes over time or across locations more easily. Normalized methods can include setting base year, for example 2000 equal to 100 and adjusting all values related to that, or rescaling to fall within 0 to 1 range or 0 to 100 range. Okay, so this is what it has been done. You can see here every value is between 0 to 1 range. In our case, we can try to see the relationship between either the actual sale price and this Zillow Home Index value normalized, or between adjusted price. So for that we can simply create a scatter chart. Let's copy this and we are going to create a scatter chart, and for that scatter chart I will just remove this. Let's keep average sales price here and the ZHVI index normalized. So the normalized value is given as IDX. So we will put it here, and actually not in values but here. So first of all we'll put ZHVI on x-axis and we want to see whether it has some kind of effect on adjusted sales price. We will make don't summarize here, so because we want to see for every value, and don't summarize here. So here we can see this is the relationship between ZHVI index and adjusted sales price, and for different index values you can see different prices. Even if we simply use the actual value versus sales price, the actual value, then also we can see a trend like this. In the example that we have here, so this is scatter plot visualizes relationship between two variables, which is our actual Zillow Home Index value in Zillow Home Value Index and actual price. Most sale prices are concentrated under 2 million regardless of ZHVI value, which ranges from 310,000 to 430,000, that you can see here. This indicates that ZHVI is not a direct predictor for sales price of individual homes, but rather a general market indicator for that area. Spread in the sales price, you can see there is a wide variation in sales price for at each ZHVI level. You can see at any given ZHVI you see homes sold under 1 million to over 6 million, likely due to property size, type, condition and location. There are some outliers also, and this shows a weak correlation. The spread of dots show no stronger linear trend, suggesting that while ZHVI gives a regional estimate, it doesn't strongly correlate with individual home sale price. So yes, we are using that, and that's how we can decide whether we want to keep this variable for prediction or creating model or not. Next variable is number of living units, where we have value range from 1 to 5. So it is number of living units, and this basically indicates number of residential units on the property. So for that also we would like to see, so because it has either 1, 2, 3 or 5, so we would like to see average pricing on the basis of number of living units. So we will simply copy this chart. Let me adjust the sizes, and then I will use a clustered bar chart for it, and instead of property type, I will go with number of living units. So this is number of living units in y-axis. So you can see for 1, if the living unit is 1, what is the average of sales price adjusted? Okay, this is for 5, this is for 4. So you can see how pricing is varying. For 1 it is lower and for 5 it is higher. This is average at average price, so we will rename it here. So average sales price by number of living units. So when we are seeing these colors, for example, we have bars here. There it is called as bar, here it is column. One and the same thing. One is horizontal, one is vertical. In color we can do a fx or function or conditional formatting where we can select gradient, and on the basis of average of adjusted sales price, we can say the lowest value will be in this color and highest value will be in this color, and we'll click OK. So this way you can see a gradient like color here, okay, where it also indicates the minimum and maximum value. So this is one way of showing the values. Dark color means values that are higher in magnitude. In data comparisons like this, where we are trying to see the correlation, we can also click on this particular icon and we can enable a trend line, okay, which is not visible because its color is dark. We can use a lighter shade color here, so that trend line will be visible, and that trend line also is almost parallel to x-axis, which indicates a very weak correlation. Next is square foot. This is also a numerical value, a continuous numerical value like a square foot lot. So for this also we will be using a scatter plot. Whenever we have to see relationship between two numerical values or correlation between them, we use this. And here I am going to use, instead of ZHVIPX, I am going to select the square foot lot, and I am going to say don't summarize. So here we have sale price, we can put adjusted sale price also. And don't summarize. So from here we can analyze that when a square foot lot is around or around 5543, or when we have smaller values, we can see some kind of correlation. But when it comes to higher values, obviously there are many outliers here, and in this case also a weak correlation is there. So like just from the square foot lot you will not be able to predict the price. Yes, but if the square foot lot size is smaller, then we can see some kind of correlation. So how to check that? We can click on this, and here we also have a zoom slider. This zoom slider is used to adjust things. So for example, I will not select y-axis, I will just select it on x-axis, and if I try to remove the outliers, okay, then we can analyze what type of trend is there. So a small linear trend is there, although very weak correlation, but you can see. If we go further, so you will be able to see for your range, for example 0 to 80k. So this way you can adjust and analyze that if you try to remove outliers manually, how that relationship is. So let me keep it at this value. Okay. So this is a square foot lot and adjacent or adjusted sale price relation. So a square feet lot is lot size, and a square foot to living is total living area in a square feet. So here we would like to see distribution of total living area. So square foot to living, and to see the distribution of something, let me use a stack chart. I will first demonstrate it using the stack chart. So this is also same. I will just copy it. Now here we have the square foot in basement. So this is square foot to living. So here I will put it on y-axis, and for every property we have some property ID, right? So we will count how many property IDs are in different range. So of square foot to living, you can see distribution like this, right? So because here the range, the bin size is very small, and you can see that how the data is distributed. Most values are between this range, right? Square feet to living 1680 square feet. Most of them are less than 4000 square feet. Now here analyzing the data is difficult, so we can create groups here. So we can go to these three dots and create new group, and instead of bin size which is given as 180 or number of bins that are 57, we will say let's keep the number of bins to 10. This way every bin size will be 1000 square feet approximately. And now when you will keep that, it will show you the same kind of trend you can see here, or we can adjust it here. For example, let's edit the group. Let's say number of bins are 15, so you can adjust accordingly. Okay, and on the basis of your number of selected bin size or your bin size, you will be able to see how many different properties are there. So if the count of properties is 2000, when the square foot of living is 370, and square foot of living is 1000 when it is 1700, 2000. So most of the properties are when the square foot to living is 1000. Now we want to see the average pricing also, because that is something that we are keeping as target value here. So for that we will simply convert this into line and stacked column chart. I will disable the data labels for now, and in line and stack what happens, this is the same distribution, but we get an extra line axis where we can put average sales price, and when we it will be average, so you can see how the average sales price is changing according to square foot of living, and you can also see number of properties in that range. So average of sales price to square foot of living is obviously when square foot of living is more, average sales price is also more. So we can see a definite linear trend here, although not perfectly linear, but yes. So this type of data is telling you the distribution as well as showing you how many properties we have of different square foot area. Next we also have other columns, so let's see. This is square foot in basement, number of bathrooms, bedrooms, so we have these kind of parameters. So in the similar way we can also find out correlation between a square feet in basement and adjusted sale price here. So this is just, it has a bit of more correlation, but not very strong. But yes, we can also use a line chart. Just giving you an example. For example, on x-axis, if we keep square feet in basement, and on y-axis we keep average sales price, so you will be able to see that as well along with a trend line. So this is also average price by square feet in basement, which we can see when that is increasing, we have some kind of increment in the overall average price also. And here we can adjust the line. So for line we are going to select a different color, and we can give a simple shaded area also if needed. Similarly, we can also show average price by number of bathrooms in that property, and you can see it is highest in case of around 7.25 number of bathrooms. Let's copy this, and here we can show number of bedrooms also. So we'll just select bedroom. Similarly, we can see the average of adjusted sales price by number of bedrooms. Like, so that's why here for number of bedrooms we are putting in x-axis, and on y-axis we are putting average of adjusted sale price. You can also convert it to a stack column chart, but we are going to use this one. Similarly, building grade is given, so I will simply create a new group for building grade. Here minimum value is 3 and maximum value is this. So I will just keep 10 number of bins. It will be on the basis of building grade quality, and I will just copy this chart and put it just below it. And here I am going to put the number of bins on x-axis, and you can see on the basis of x-axis how many properties do we have, and on the basis of building grade, like when building grade is around 12, what is the average price? When building grade is very low, what is the price? We can see a very strong correlation here, and it is also showing us the number of properties in each building grade as well, which we can see most of them are in building grade of 7. We can also convert it to a stacked column chart, and there you can see a very strong correlation that building grade is 12 and average price is also very high. So on x-axis kept building grade bins, on y-axis average of adjusted sales price. We also have information of year in which this property was built. So like if more year have passed, has the property price declined or increased or whatever it is. So we can create a line chart here, and in that line chart we can put on x-axis we can put the year built. So let me select that this is year built. This year built will be shown here, and on y-axis we will put the average sales price. So you can see on the basis of year built how the adjusted sales price has varied over time. But sum of also means it is based on number of properties. We will see the average price. So this is average of adjusted sales price by year for different type of properties. Let's say we want to see for single, so you can see now entire data for single, for multiplex, or for town. So you can see for different type of properties how it is changing. And what we can do is we can select this, and here we can see line. In line we have solid style, but we will select smooth here, okay, and enable the data labels. And we can definitely tell that there is some kind of effect on different years on the average adjusted price, and this is a simple way of finding out which variables have more effect on adjusted sale price, which variables have no effect, like very weak correlation. And on the basis of that, when we will try to create a model for this house price or house sales price predictor model, so in that we will definitely keep some of them and we can ignore some of them. So for example, we have not used any variables like property ID, document date. This type of variables are of no use for model, so that's why we have kept them separate. So try this and see if you are able to create this. We have more variables here. You can similarly use more variables also, like we can use other things like whether it's a new construction, yes or no. Those type of values can also be used as a filter. and that is something that we are going to see in the second part. Thanks for watching this part. Please like this video, subscribe to our channel so that you will get notification when we will post something like this. This is additional thing, we are adding a slicer here. So we have just added a slicer because we just want to see that with new construction, yes or no, whether it's false or true. On the basis of that, how the property prices vary, so we can use it as a tile, and in that we can keep the values background color as this color and font color as this color. Okay, so let's use that. So if new construction is false, you can see a little effect. For new construction true, you can see we do have, for example, in average price in bathroom, a very straight away linear trend, in bedroom also, and here also. So you can see on the basis of different values, or if the new construction is true or false, how it is varying.